Hi, today's lesson is on solids. What are solids? By solids, we mean a three-dimensional geometric shape. Well, a stone is a solid, but we won't be studying the properties of stones. We will be studying the properties of well-known, well-defined geometric shapes, like cubes, cones, spheres, boxes, and so on. What is required to study the geometry of these objects? Well, in general, we need some parameters like the length, breadth, height, width, radius, slant height, depending on the object. And given those parameters, what are the two things we need to find out? Well, the two main things that define a solid are its volume and its surface area. Its volume and its surface area. Why is the volume important? Well, the volume tells us how much stuff I can put into the solid. So how much I can fill into a box or how much ice cream I can put into a cone. That's defined by the volume. What about the surface area? Well, the surface area tells me what the solid is made up of. What is the external part of the solid, the part I see? What is the area of that material? So suppose a box is made out of wood, then how much wood do I need to make that box would be given by the surface area of the box. The first object we study is the cube. Everyone's familiar with the cube. A dice is a cube and many boxes come in the shape of a cube. What defines a cube? A cube has three dimensions. It has a length, breadth, and a height. And in a cube, what's important is length is equal to breadth is equal to height. So all three are equal to the same measure. We call that the side length of a cube. So the side length of a cube is equal to L. Could be L meters or L centimeters or L feet. So if the side length of a cube is L, let's find out its volume. Well, the volume is simple. I find out the area of the base. This is the base. Since the base is a square, its area will be length square. And then this area goes all the way up the height to create the box. So the volume will be area of base into height. In this case, it will be L square into L because the height is also L. It will turn out to be L cube. So the volume, which is area of the base into height, turns out to be L cube centimeter cube. Let's assume the side length was given in centimeters. Remember that volume is measured in units cube. What about the surface area? What are the surfaces of the cube? As you can see, there are 6 surfaces that make up the cube. And all of them are squares. What's the area of that square? Each square has area L square. And since there are 6 of them, the surface area of the cube is 6L square centimeters square. Centimeter can of course be replaced by any unit. So the volume of a cube is given by L cube. And the surface area of a cube is given by 6L square, where L is the side length of the cube. Find the amount of paint needed to paint a wooden cube with volume 3375 feet cube. Amount of paint needed. So what are we talking about? The amount of paint needed is needed to cover the cube. So it has to cover all the 6 squares that make up the cube. Essentially, we need to find out the surface area of the cube. So find surface area given volume. I know the volume of a cube, it's given by L cube. So L cube is equal to 3375. Let me try to factor 3375. So that's 1125 into 3. 3 would go in again. That will be 3, 3 sevens are 21. 375 into 3 into 3. That 3 goes in again. That's 125 into 3 into 3 into 3. 125 is 5 cube. So it's 5 cube into 3 cube, which I can write as 5 into 3 cube, which is 15 cube. So L cube is 15 cube. So of course L is 15 feet. So I've found the side length, it's 15 feet. Now to find the amount of paint is equivalent to finding the surface area. Surface area of a cube is 6L square, which is 6 times 15 square, which is 6 times 225, which will be 1350 feet square. The answer is D. So this was a straightforward question. Given the volume, find the surface area. To find the surface area, we need the length. Find the length using the volume, and then use the length to find the surface area. The rectangular prism or the box. So the box is very similar to the cube, except that the 3 dimensions can be different. So here we'll call them the length, the width, and the height. The width is also called the breadth. Again, I draw the hidden lines to show the other 3 sides of the cube. What's the volume of this cube? Again, it's the area of the base times the height. So volume is area of base times height. What's the area of the base? Well, the area of the base is a rectangle. So its area is length into width. So that's length into width. And what's the height? The height is given as h into h. So the volume is LWH or LBH. Length into width into height or length into breadth into height. What about the surface area? What's it made up of? The box is made up of 6 rectangles. So there's a rectangle in front, and there's an identical rectangle behind. There's a rectangle on the side and on this side, and there's a rectangle on top and an identical rectangle below. So that there are 3 pairs of identical rectangles, and we need to calculate each of the areas and add. So the base has area length into width, the side has area height into width, and the front has area length into height. So these are the 3 different shaped rectangles, and there are 2 of each. So into 2, into 2, into 2. And I add. Take 2 common. It's length into width plus height into width plus length into height. And that's the surface area. A cube and a rectangular prism have equal surface areas. Find the volume of the cube if the prism has dimensions 18 by 10 by 9. Firstly, it's given a cube and a rectangular prism have equal surface areas, and the dimensions of the rectangular prism are given. So let's quickly find its surface area. The surface area of prism is 2 into length into width, that's 180, plus length into height, that's 18 into 9, that's 162, plus width into height, that's 10 into 9, that's 90. Length into width plus length into height plus width into height. So what does this turn out to be? That's 2 into 180, 270, 432 is equal to 864 meters square. It's given that the surface areas are equal. So 6L square, which is the surface area of the cube, is also equal to 864. So L square is 864 divided by 6. That's 144. So L turns out to be 12. Root of 144 is 12. I have the length of the cube. It's 12 meters. What's its volume? L cube. That's 12 cube That's 144 into 12, which is equal to 1728 meters cube. And that's answer E. Find the length of the diagonal of the cube shown alongside. So what is this diagonal of the cube? Let's just draw the other hidden lines so that we know what's going on. So this diagonal of the cube is starting at the back vertex of the cube and finishing at the front vertex of the cube. So it's going across the body of the cube. It's going through the cube. How do I find its length? Well, it's a diagonal, but I can follow it by going down the height of the cube and then across the base of the cube. And this is a 90-degree angle. Because it's a vertical line, this is the vertical line and this is D, which goes across the base. So we have a right angle triangle and this is my diagonal. This is diagonal of the base and this is the height and this is the diagonal of the cube. That's the situation. So let's find this D. I've called it D here. Let's find this D, which is the diagonal of the base. So let's not call the height height, let's call the height L, because all dimensions are L. It's a cube. So if two sides of the base are L and L, what is its diagonal? It's a square base, of course. So we want the diagonal D. The sides are L and L. So D is equal to root 2L. Simple application of Pythagoras. Now this D is root 2L. Let's find the diagonal of the cube. So let's call the diagonal of the cube X. Again, Pythagoras, we know that X square is L square plus root 2L square. So it's L square plus 2L square, which is 3L square. So X will be root 3L. And that's my diagonal of the cube. The diagonal of the cube is root 3 times the length of the side of a cube. The length of the side of the cube is given as 7 in this question. So it turns out to be 7 root 3 centimeters. Simple application of Pythagoras theorem twice. Once find the diagonal of the base, then find the diagonal of the cube. Let's move on to our next object, the sphere. The sphere is just a ball. It's a round object. And what do we need to define a ball? A ball is defined by just one parameter, the radius. So the radius R. What's the formula for the volume of a sphere? It's 4 by 3 pi R cube. What's the surface area of a sphere? The surface area is 4 pi R square. Those who know a little bit of calculus can see that the surface area is the differential of the volume. Of course, don't worry about it. You're just supposed to know the two formulae. 4 by 3 pi R cube and 4 pi R square. A sphere is shrunk till it has 1/4 of its original surface area. By what fraction has the volume of the sphere shrunk? So if it shrinks, what happens to the sphere? It gets smaller. So what's getting smaller? Well, the radius is getting smaller. That's why the surface area and the volume are also getting smaller. So let's call the original radius big R and the new radius small r. We need to figure out how big R has changed to small r, or the relationship between the old radius and the new radius. So I know that the surface area has shrunk. So the original surface area was 4 pi R square. The new surface area is 4 pi little r square, and that is 1/4 of the original surface area. 4 pi R square. It's 1/4 of the original surface area. So I get R square by R square. I can cancel out the 4 pi's. I get R square divided by big R square is 1 by 4. Or taking square roots, r by r is 1 by 2. So the ratio of the new radius to the old radius is 1 is to 2. R is to r is 1 is to 2. The radius has become half. As the surface area became 1/4, the radius became half. By what fraction has the volume of the sphere shrunk? Well, that's easy now. The original volume was 4 by 3 pi r cubed. The new volume is 4 by 3 pi little r cubed, which is 4 by 3 pi r by 2 cube, because little r is big R by 2, it's half the original radius, which is 1/8 of 4 by 3 pi r cube. I just pull out the half cube to get a 1/8. So it's 1/8 the original volume, because this is the original volume. So it has shrunk to 1/8 its original size. The answer is B. So that was easy enough. Given the ratio of the surface areas, I found the ratio of the radii, and I used the ratio of the radii to relate the new volume to the old volume. Well, there's a message in all this. What it tells me is, if the radii becomes half, then the surface area becomes 1/4 and the volume becomes 1/8. That's true for any such shrinking. That's because the formula for surface area involves squaring the radius, and the formula for volume involves cubing the radius. So whatever ratio change occurs in the radii, a square of that change will occur in the surface area, and a cube of that change will occur in the volume. The cylinder. Well, this is just a can. We all know this shape. Let's look at the important parameters. So cylinder is made up of two circles that are connected vertically. So the radius of the circle is important. There's a circle at the base, there's a circle on top. They both have the same radius. And this is the height of the cylinder, what makes it a three-dimensional object. And this is, of course, curved. So what's the volume of the cylinder? Again, clearly, it's some base area that has been multiplied all the way up, a distance of the height. So volume of cylinder is again base area times height. What's the area of the base? The base is a circle of radius r. So its area is pi r squared. What's the height? The height is h into h. So the volume is pi r squared h. What about its surface area? How many surfaces does it have? It has a top circle, it has a bottom circle, and it has this curved surface. That is the entire body of the can. What's the surface area of the top? Again, it's a circle, so it's pi r square. What's the surface area of the bottom? That's also pi r square. So we have 2 pi r square, which gives us the surface area of the top and the bottom. And what's the curved surface area? Well, if I were to cut open the cylinder here and unwrap it, I'd get a rectangle. This would be the width of the rectangle, the height, and what would be the length of the rectangle? The length of the rectangle would be this entire length, because I'll be unwrapping this entire can and opening it out. And this length is the circumference of the circle. So it's 2 pi r. So the curved surface area is equivalent to a rectangle of width, height and length 2 pi r. So it's equal to 2 pi r h. When I add these two areas, I get the total surface area. So I get 2 pi r square for the top and bottom plus 2 pi r h for the curved surface area. And that gives me the entire surface area of the cylinder. This cutting open and unwrapping is a very elegant way of figuring out the area of the curved surface. A cylindrical drum of radius 2 meters and height 4 meters is half full of water. So we have a cylindrical drum, radius 2 meters, height 4 meters, half full of water. A tap at the bottom is open and water flows out. So water flows out at the rate of pi meters cube a minute. Pi meter cube per minute. So what's changing when I open the tap? Well, the water is flowing out from inside. So the volume is changing. Volume is changing. Volume of what? The volume of water is changing. How many minutes before the drum is empty? So what's the volume of water in the beginning? This is the volume of water in the beginning. So the volume of water is in the shape of a cylinder with radius 2 and height 2 because it's half full. So volume of water is pi r squared h, which is pi into 2 square into 2. Since it's half full, its height is 2. That's 8 pi meter cube of water. That's the amount of water in there. When the tap is opened, how much water flows out per minute? Pi meter cube per minute. We need to empty out 8 pi meter cube. Obviously, that's going to take 8 minutes. The answer is B. A tree trunk is shaped to form a solid cylinder of height 5 feet and radius 2 feet. So here's your tree trunk. Its height is 5, its radius is 2. And it's a solid trunk. It is then cut parallel to the base to form two identical cylinders. Cut parallel to the base means it's cut like this. It's sliced here to form two identical cylinders. You get one cylinder like this and you'll get another cylinder like this. So what do we know about these cylinders? Well, their radii are the same and their heights are each half the height of the original cylinder. By how much has the total surface area of the two figures increased? The 4 dummies method for doing this is, since you know all the dimensions, you know the radii and the height, you calculate the original surface area. You calculate the new surface areas of the two cylinders and you subtract. But let's just pause and look at the figure. What's exactly changing? What's the surface area of the original cylinder? It's these two circles plus this entire curved surface. When I cut it into two, this curved surface doesn't change. Half the curved surface is here and half the curved surface is here. So the curved surface of the two new cylinders adds up to the curved surface of the original cylinder. What has changed? There's one top here and there's one bottom here. What's more, there's one bottom here and one top here. That's the additional area. And that's the only additional area. One extra bottom and one extra top. So what's the change? The change is these two areas. Each is a circle. So each has area pi r squared. So the change is 2 pi r squared totally. So 2 pi into radius 2 square, that's 8 pi. So my change in surface area is 8 pi meters square. Answer is B. Neat way of doing it. I see what the change is and I only calculate the change. I didn't have to calculate entire surface areas. The cone. Having done the cylinder, let's now work with the cone. The cone again has two important parameters, the radius and the height. What's the volume of the cone? Well, the volume of the cone is 1/3 the volume of the equivalent cylinder. If I had a cylinder of the same radius and same height, its volume would be pi r square h. And the volume of the cone is 1/3 of that. It's 1/3 pi r square h. What's its surface area? Well, that's more interesting. Well, it has a base which is a circle. So it has a pi r squared. And it has a curved surface, which is what forms the shape of the cone. And this curved surface has a slant height of L. Let's call L the slant height. And the area of this curved surface is given by the slant height. So curved surface area is given by pi r L. So H doesn't directly come into the formula, but the slant height comes into the formula for the curved surface. So let me just complete this. Total surface area would be pi r square plus pi r L. Now how are R, H and L related? If this is a right cone, that means there's a right angle between the height and the radius. Then we know that L is the hypotenuse of this triangle. So L square will equal H square plus R square. The slant height is the hypotenuse of a triangle formed by ABO, where the radius and the height meet at the center of the cylinder. That triangle is a right angle triangle and the slant height is its hypotenuse. A cone and a cylinder have equal heights and equal volumes. What is the ratio of the radius of the base of the cone to the radius of the base of the cylinder? So here's a cylinder. Here's the cone. Why have I drawn the cone broader? Well, because they have the same height. The heights are the same. So if the radius of the cylinder is r and the radius of the cone is big R, then of course the radius of cone has to be bigger for them to have equal volumes. So let's write the volume. Volume of cylinder is pi r square h. Volume of cone is 1/3 pi big R square h. They're given to be equal. So pi r square h is equal to 1/3 pi capital R square h. Pi and h can be divided out. And I get r square is 3 little r square. Capital R square is 3 little r square. What is the ratio of the radius of the base of the cone to the radius of the base of the cylinder? So r square by r square is 3. So r by r is root 3. So the ratio of r is to r is root 3 is to 1. That's the answer we are looking for. E. The blue sector has a radius of 12 centimeters. 12 centimeters. It is folded to form a right circular cone. So how do we fold it to form a right circular cone? Well, basically we join these two sides and we lift this point up. So it becomes a cone like this, where those two sides are joined. It's like making a tent out of this piece of cloth. Suppose this was a piece of cloth, then you would form a tent, and where these two sides meet is the opening of the tent. I've joined those two sides, and so these two sides are basically the flap of the tent, so they're the slant height, 12. So the radius of the cone becomes the slant height of the cone. Okay, so let me draw the cone better. And 12 would be the slant height of the cone. Find the volume of the cone. So now if I know the slant height of the cone, I need to find something more. I need to find the radius and the height. Let's first see what becomes what. Well, this entire thing, which is the cloth that makes up the tent, would become the curved surface of the cone because it would be folded to make the cone. So what is the area of this blue region? Area of blue region is 3/4 of the area of the circle. So that's 3/4 of pi r squared. That's 3/4 of pi 12 square. And that's becoming the curved surface area of the cone. So this is equal to pi r L of the cone. That's the curved surface area of the cone. We know L is 12. So let's equate. So 3/4 pi 12 square is pi into r into 12, which is the slant height of the cone. You can cancel a 12, can cancel the pi, and we get r is equal to 9 centimeters. So the radius of this cone is turning out to be 9 centimeters. Okay, now it's easy. The slant height is 12, the radius is 9. What's the height? So by Pythagoras, in this triangle, I find the height. Height square is equal to 12 square minus 9 square. That's 144 minus 81. So height square is equal to 144 minus 81, 63. So the height is root of 63. That's 3 root 7. So the height is 3 root 7 centimeters. I need to find the volume of this cone. Volume is pi r square. 1/3 pi r square h. That's 1/3 into pi. R I know was 9, so that's 9 square into h, which is 3 root 7. 3 and the 3 cancel. So that's 81 pi root 7 centimeters cubed. That's the volume of this cone. 81 pi root 7, that's answer A. So our answer is choice A. So let's recap how we did this. We took the blue region. The blue region, when folded, would become the curved surface of the cone. So I equated the area of the blue region with the area of the curved surface of the cone. What is the slant height of the cone? Well, the radius of the blue region becomes the slant height of the cone when you fold it. And I use this information to find the radius of the cone. The radius of the cone having been found, I now use Pythagoras to find the height of the cone. Knowing the height and the radius of the cone, I can now find the volume. So the important thing here is to imagine how that blue region became the cone. An ice cream cone of base radius 5 inches and height 10 inches is filled with ice cream to a height of 6 inches. So it's filled to a height of 6 inches. So here's the ice cream. How much ice cream does the cone contain? How much ice cream does the cone contain? So this is the amount of ice cream the cone contains. So I need to find the volume of this new cone. I need to find the volume of this smaller cone. So I need the radius of the smaller cone and the height of the smaller cone. Well, they've given me the height of the smaller cone. They've said it's 6 inches. But the radius isn't 5. 5 is the radius of the entire cone. This is a much smaller radius. Let me see if I can relate the two radii. So I just draw the two triangles that define the amount of ice cream. So I've drawn this triangle and this triangle. So this entire height is 10, this height is 6, this radius is 5. Clearly these two triangles are similar. They have a 90 degree each. They have a common angle. So the third angles will also be equal. So the radius of the ice cream part of the cone can be set up as a proportion. R over 5 is equal to 6 over 10. Radius upon radius is equal to height upon height. So the new radius is 3/5 into 5 is equal to 3 inches. So the radius of the ice cream part of the cone is 3 inches. Let's find the volume. Volume is 1/3 pi r square h, which is 1/3 into 3 square into 6 into pi, of course, which is 18 pi inches cubed. So the volume is 18 pi inches cubed. The answer is B. So interesting question in similarity of triangles. The two cones are similar, therefore their radii are in the same proportion as their heights. Okay, so we are done with all the basics of solids. We looked at how we use the parameters to find out volumes and surface areas, how given a surface area we could find the volume and vice versa. We related similar shapes and we learned how to fold a sector of a circle into a cone.